Hi, I'm Vishal. Let us explore about why the speed of light is constant. From our daily experience, we know that speed gets transferred from one moving object to the other.
Let us experiment starting here. If I throw the ball,
It reaches a point there. Now, if I run along and throw the ball, it reaches a farther distance. This very principle of velocity addition is used in the launch of spaceships. Multi-stage rockets are used to achieve very high speeds, where the speed of one stage is added to the next. Now, let us try to add speed to light. If we repeat our experiments with laser flash, what happens? If we mount a laser on spaceship, for all three scenarios, the speed of light is constant. Why? What works around us is not working with light. Why aren't we able to add speed to light? As we all know, the speed of light in vacuum is constant with a value of 3 lakh km per second. Isn't it strange? Let us give some thought to our experiment. The constant speed of light has puzzled many scientists. The space around us is three-dimensional, consisting of the horizontal x-axis, vertical y-axis, and the depth as z-axis. If I move along, say, the horizontal x-axis, my speed is distance traveled by total time taken. The Earth rotates around itself and around the Sun. Everything moves in the universe. If we take a closer look at our experiment, because of the Earth's rotation, my position has changed as I observe the spaceship and the light from it. So my coordinates have changed from the original reference at the origin. In a similar way, the coordinate plane for a spaceship has also changed. I, being stationed on the Earth, the spaceship in the outer world, the frictious forces affecting us are different. So the distance we measure at very high speeds near to the light speed has an error due to the fixed coordinates. This means that there is no absolute reference frame in the universe. Taking a relook at our experiment, if we measure the speed by distance and time for our experiments, the speed of the spaceship has to add up to the light, but it doesn't happen. Why? Wait, there's something wrong here. This means that the fourth axis time plays a crucial role. There is an interplay between time and space. Both space and time change to keep the speed of light constant. There is one more problem to be tackled. If the distance is changing by delta x, for the speed of light to be constant, the denominator, time, has to be changed to keep the light speed at c. This is called spacetime. Spacetime is a continuum which records all events. To keep the speed of light constant, does the spacetime change? Isn't it weird? Are they intelligent like us to adjust? Without reference, you won't be able to measure the distance between yourself and the person standing next to you at shoulder's length because your shoulder length differs from his shoulder length. To put the question in the right perspective, how do we measure between two reference frames in the absence of absolute reference? We need a scale which is constant across the frames to carry out measurements, without which no comparison can be done. Albert Einstein has postulated it in the most eloquent way. Did Einstein derive the speed of light as constant? No. He intuitively assumed and set the speed of light as constant, and through sound reasoning, he justified why it is so. Let us see how it is with our experiment. One of the systematic limitations of the measurement of high speeds is what we measure differs from what actually happened. The curved flight path of the spaceship, as seen from our reference plane, is actually a straight line in the reference plane of the spaceship. Similar would be in the time axis. The curved path taken by the spaceship can be analyzed by a series of right angled triangles. Because the spaceship is traveling near light speed, say c by 2, the light arrived at the Earth is seen as inclined, while the spaceship looks at it as a vertical line. Applying Pythagoras theorem, c square t square equals to v square spaceship into t square plus c square into t prime square after algebraic reduction. Lorentz transformation maps between reference frames my position at the origin with x, ct as reference frames. For the spaceship, it is x prime, ct prime. Both measure the speed of light constant shown by the 45-degree line. If the speed of the spaceship reaches the speed of light, the equation reduces to c equals to delta x by delta t. Hence, the total speed becomes c. Here we have the proof that speed of light is constant across all systems. Speed of light is a universal constant. It is a constant which holds good at the world around us, at atomic levels, and at galactic levels. It is a scale to measure the universe.